Our next speaker, Emily Schechter. She is a product manager for the Google Chrome security team, and she's going to talk to us today about evolving the security indicators in Chrome and what we can do to make secure browsing a better and more effective experience for everyone. Thank you.
All right, thanks for the introduction. I'm really happy to be in Seattle today. The weather, it's significantly nicer than it was in San Francisco, so happy to kind of escape the fog and come to Seattle. So as she said, my name's Emily Schechter, and I'm the product manager for the Chrome security team at Google. One of my focuses on usable security. So at Chrome, we believe that security features should be helpful when you need them and visible when you don't need them. But this is actually really difficult to get right. And we see many examples of places where security UI that's supposed to be helpful is actually quite confusing or not really effective. So in Chrome, we treat usable security like a science, and we do user research to help us pick how to represent security in browser UI. So today, I will explain 3 user-facing security changes that we've made recently over the past few years. And I'll talk through the user research that we use to make these changes, and then I'll explain kind of the ecosystem effects that the changes had. So the 3 changes that I will focus on, first I'll talk about making our negative security indicators more helpful and noticeable when sites do have a security issue. Then I'll talk about making our positive security indicators more invisible when there's no security problem. And finally, I'll talk about our recent explorations to help users understand URLs more. So I'll start with the negative security indicators. So in Chrome, we indicate connection security with an icon in the address bar. And we've changed this icon over time to more clearly explain the risks of non-secure HTTP. So this is what our icon for all HTTP sites used to look like. And we thought this was a problem because it really doesn't give users a warning, and it doesn't really at all communicate the risks of using non-secure HTTP. And we would like to represent all non-secure HTTP sites with this dangerous triangle icon. But we actually thought that introducing this icon right away, it might cause harm. So we've seen from some prior research that when users see warnings too many times, they get what's called warning fatigue, which means they stop paying attention to warnings at all. We also, we don't want to induce warning fatigue, but we also don't want the internet to seem like a scary place, right? We don't want people to be kind of afraid of using the web or stop using the web. So we're on this mission to be honest, but without inducing chaos or panic. So we created this plan to slowly introduce browser UI so that we can balance exposure to warnings with gradually increasing our honesty about the lack of security in HTTP connections. So we started this in January 2017. We began showing warnings on HTTP pages with passwords or credit card form fields. And we chose this as a first step because there's limited user exposure to HTTP password and credit card pages. So there's kind of this low risk of warning fatigue. And also because it's conceptually pretty understandable to users that there might be some risks involved with transmitting a password or a credit card online. And we actually did see great impact from this change. On Chrome desktop, we actually saw 23% reduction in the fraction of page navigations that included a password or a credit card form over HTTP. So we decided that we were ready to take the next step. And then starting in October of 2017, which was Chrome 62, we started to show this not secure warning in 2 additional situations. So first was when users enter data on any HTTP page. So as shown here in this little animation, the warning expanded out when you type into an HTTP page. And we also thought that when you're browsing the web in incognito mode, you might want to know when your connection isn't actually private. If you're not familiar with Chrome incognito mode, it's a privacy feature that opens a new window where Chrome won't save your browsing history so that others who use your device won't see that activity. But it really doesn't change at all whether your connection to those sites is actually private to those on the network. So in Chrome 62, we also started showing this not secure warning on all HTTP pages that are visited in incognito mode. And then finally, in July of this year, on Chrome 68, we were finally able to mark all HTTP pages as not secure. And this really represented kind of a huge milestone for us in reversing what our security UI is. I'm really proud that we finally were able to get to this point. But we're not done yet. So we did some user research back in 2016, and we found that this red danger triangle was the icon that most users understood to mean that there was a security issue. So we're going to continue our quest, and we're going to roll out this new danger triangle UI treatment in 2 steps. So the first one is in Chrome 70, which actually reaches stable channel around October 9th, just in a few weeks. We'll start showing the red UI on HTTP pages with user-entered data. And after that happens, we will analyze the effects that the red UI had. We'll see how many users were exposed to the warning. And then we'll pick a timeline to start showing the red UI on all HTTP pages. We haven't announced this timeline yet, but as soon as we do, I'll write a blog post so that sites will know that it's coming. And these changes are not just happening in Chrome. They're happening around the web ecosystem. So here on the left, you can see Firefox's security UI. On the right is Safari. And both these browsers are showing a really clear, not secure UI when a user enters a password on an HTTP page. And so from these changes, not just in Chrome, but around the whole web ecosystem, we've really seen measurable impact. So we have a public transparency report that shows the HTTPS status of the top 100 sites on the web. We started publishing this report in January 2016. And at the time we started publishing it, 24 of the top 100 sites were defaulting to HTTPS. And now we actually see 81 of those defaulting to HTTPS. And if you go on the Chrome transparency report, the HTTPS transparency report, rather, it's at g.co/HTTPS. You can also see a lot of other interesting metrics, like the actual percentage of page loads over HTTPS that are happening in different Chrome platforms, like Windows and Android and Mac. And you can also see information about the HTTPS status of services at Google, like Gmail and advertising and that kind of stuff. So I want to call out a few key things that made this change successful. The first is outreach and comms. So we took a lot of effort, to announce all of these changes far ahead of time, so that sites that were still HTTP would have ample time to migrate to HTTPS before users actually started seeing the warnings. We also know enterprise is an important segment of Chrome users. Obviously, it's important here at Microsoft as well. So we did provide an enterprise policy so that IT admins could turn off the warnings for the enterprise if they wanted to. And finally, I mentioned ecosystem support. So as I mentioned, Firefox and Safari started showing the warnings as well. Also, Let's Encrypt, which is a free and automated certificate authority, started offering these free and automatic certificates. And countless developers, and security and privacy advocates kind of evangelized all of these changes, which really made a difference and really allowed the project to succeed. If the story was just like Google is pushing the web to HTTPS, it would have been really a much weaker story. So having kind of full ecosystem involvement is really important to support these kind of changes. So I previously mentioned that at Chrome, we believe security features should be helpful when you need them and invisible when you don't need them. We think users should expect that the web is safe by default and that they'll be warned when there is an issue. So I just talked through how we made our negative security indicators more helpful, more prominent, but we also want to make our positive security indicators more invisible so that the default unmarked state is secure. So this is what Chrome's positive security indicators for HTTPS pages looked like back in 2016. And we did some research that I previously mentioned, that 2006 research. It was called Rethinking Connection Security Indicators. And one of the things that this research told us was that text, human readable strings are really useful to accompany connection security indicators, and that the word secure in particular really helped users to understand what the green lock icon meant. So we added this word secure next to the green lock icon. And because the word secure with the green lock icon was much more universally understandable than just the green lock icon or the HTTPS scheme itself, we implemented a change to remove the HTTPS scheme from the steady state. And this change actually originally landed in Chrome 69, which came out just a few weeks ago. Unfortunately, we found some issues with the implementation, and we ended up rolling it back. But we do plan to roll this out again in the near future. We also realized that the secure string was actually sometimes problematic because it could be overpromising, right? In particular, some users might think that secure actually means safe, or that the site content would be not spammy or not spoofing, when it really is just referring to the secure network connection. So we also decided to remove the secure string. And you can see here, this change actually shipped at the same time that we also tinted the lock icon gray. We did this because we redesigned most of the top Chrome UI in Chrome 69, which came out a few weeks ago. But we thought that the color of the icon actually is less important because each of the security icons is represented with a distinct shape. And eventually, we would like to remove the lock icon completely so that the default unmarked state is secure. We don't have a timeline for this change yet either, but when we do come out with a change, we'll be sure to announce it ahead of time so that developers can make changes. So along these same lines, we wanted to study the effects of extended validation certificate UI on user behavior. So here you can see 3 of the conditions that we're studying. So the top is the standard Chrome UI treatment for mint.com with an extended validation certificate, which in this case shows Intuit. The middle image is with the secure string, which we had been showing for DV, HTTPS. And the final image shows no string at all, just the lock icon. So here, it's worth emphasizing all of these UIs are corresponding to the exact same certificate, the same site. The only difference is just this experimental UI setting. And so what we're doing is we're measuring user behavior signals to see if there are any differences in like how often people are submitting a form on the page or whether people are using autofilling credit cards, less or more. And then we're going to write an academic paper on the results of the study, and we plan to submit it for peer review and publication. But we don't have any of the results yet, and we also haven't made any decisions based on the results. Some other browsers are making changes in the way that they display extended validation. So here you can see Safari's treatment for EV in iOS 11 and iOS 12. So in iOS 11, they were showing the legal entity name in the address bar. But then in iOS 12, they're not showing any EV information in the address bar. They're just showing the URL. So I mentioned we believe security features should be helpful when you need them, right? And showing the URL in the address bar is a really key piece of security UI. So that means that we're expecting web users to notice and parse and understand URLs so that they can make security decisions that are based on the URL. But imagine that you're putting yourself into the shoes of a lot of new internet users today, say users coming online for the first time on a mobile device, maybe in emerging markets, or maybe you're tech-fluent middle schoolers in the Western world. Your first experience with computers doesn't include an introductory computing class, right, or document editing, or even a desktop computer. It's just a grid of logos that are labeled with brands. And if you're comfortable with this grid of apps, it's pretty easy to understand in terms of identity, right? There's Google, there's Facebook. And if you start browsing the web, you start navigating around to some websites. So on the web, we're representing identity with URLs. Do you think you'd be able to understand just from the URL who's publishing these sites? Or do you think you would even look at the URL? Maybe you would just depend on the website content itself to give you a sense for who owns the site. But let's say you're a model security conscious user of the web, just like everyone in this room, right? So you're looking at URLs all the time to make sure that you're on the site that you think you're on. Now we have some new TLDs coming out. So does anyone know which of these actually are the real Google blog? I actually was looking for a Google blog post this morning on some changes that we've recently released. I put in google.blog, but actually it is blog.google. Or which of these is the authoritative sites for Google experiments? It's actually the first one. Let's say you're reading this URL from left to right. Do you know? OK, so you're reading this URL from left to right. Pretty hard to tell whether it's coming from google.com or not. So about a year ago, we hypothesized that visually emphasizing the important pieces of the URL and visually de-emphasizing the less important pieces of the URL might help users read URLs and therefore identify suspicious pages based on the URL. So we did some research and we tested 5 different conditions. So the first image is how we display URLs today. right? And then some of our hypotheses were, would it help if we grayed out subdomains, like in the second picture? Would it help if we removed sort of extraneous path information, like in the third picture? Would it help if we just bolded the top level domain +1, right, which is kind of just the most important security information? And finally, what about if we actually only showed the top level domain +1, we removed the scheme, subdomains, and path? So we did research. We showed users this screenshot of the real Google sign-in page with the 5 different URL bars at top, and then we asked them questions about how comfortable they would feel logging into the page. And unfortunately, we found no significant differences across any of the options. So across every option, over half of the respondents didn't notice the fishy URL, and those who did notice the URL said that they trusted it because this website was Google. So unfortunately, we haven't really figured out this problem at all, right? And even if we did figure out a way to make the URL less tricky, about half people wouldn't notice anyway. But URLs are great for many things too, right? Which is why we show them in all of our UI. They're really great for sending links to really specific things, right? And here we get a hint that this is going to be a product page for some kind of product on Amazon. You could copy and paste this to one of your friends to share a specific link easily. And of course, in security land, we consider them the last line of defense against spoofing attacks if all else fails. So we're showing URLs in our most common pieces of Chrome browser UI. All browsers do, right? We're heavily depending on URLs. So in Chrome, we've started to call this problem the URL elephant in the room. URLs aren't working well, but we heavily depend on them, and we're showing them in our most visible browser UI. So in the Chrome team, we've started to discuss what URLs are used for, what of these uses they actually succeed at, and then try to brainstorm alternatives that might try to better solve each of these requirements. And keep in mind here that we're not really talking about changing anything happening under the hood. We're not talking about like dismantling DNS. It's just how we reflect these things in our UI. And we really don't have concrete plans in this area yet. We're just pretty convinced that it's a major issue with security UI that we need to actually try to solve. I actually did a longer talk just about this topic, about URLs and security UI at a conference earlier this year called Locomoco Security Conference, which is recorded on YouTube if you want to hear more about how we've started to kind of pick apart the problem, in case anyone wants to check it out. So we think security features should be helpful when you need them and invisible when you don't need them. And we're doing research and making changes in this direction. Even small changes can have large effects and can make the whole web ecosystem more secure. But the most effective change is when we're all moving together to make the web safer. So if all browsers are making security UI changes around the same time, the story is becoming much stronger, and we can really make the web ecosystem safe by default. So I'm happy to share any links to the research that I mentioned today. And if you have any questions, I'm happy to take them now. Thank you.
All right, we have runners on both sides of the rooms if there are any questions with microphones. So please raise a hand and we'll start over here. I lied. We might have runners on one side of the room, but we'll catch you.
Hi, could you share a bit about your security testing? Like, how was the testing done? Was it like an A/B testing, like between 2 different groups of users, or like how was the testing done?
Are you talking about one of the studies in particular?
Yeah, like how do you measure the different types of so you have different ways of showing the security indicators, right? So like how do you actually measure the users?
So if you're talking about the specific study with the URLs that I was just showing, that one was done offline, it wasn't in Chrome. So I believe we did it with there's like a survey infrastructure that we have where we can just show people images and then ask them questions. So it wasn't like a product A/B test or something like that. But for the changes where we're actually making the changes to the security indicators in Chrome, we have certain metrics that we can then see how things change. For example, how many people are actually clicking on the icon with the string, which is actually a button, which it pulls up like permission information, certificate information and stuff like that. or how much time people are spending in Chrome, how many pages have migrated to HTTPS, so things like that.
All right, any other questions? I think there's one over here on this side.
Hi, thanks for giving this talk. So going back to that, the sort of transition in the UI from showing changing the colors of the lock. I'm curious about, or not the lock, the opposite direction with the red that says that the site is not secure. I'm curious about what your metrics showed about. Specifically, in that transition period when you were doing animated, like when you start typing into a form and then it changes, did those move the metrics very much? It seems to me, just as a user, that I wouldn't think to look back after I start interacting with a page.
So we definitely see that when there's a larger button, people click on the button more. That's something that we definitely saw. And the animation does tend to attract more attention than not having the animation. So we actually purposely do this as well for sites that are flagged by safe browsing, which is Google's anti-phishing and anti-malware infrastructure. We purposely animate out this label so that it will attract people's attention to it. But yeah, there aren't a ton of behavioral changes besides that. I don't see any more questions, but I'm happy. Oh, she's okay. Hi.
Hi. My question is, why not trying, because referring to his question, when you start typing, it changes to red. You could also change it to flickering a few times, so making the entire attention of the user after you start typing on something that something is wrong. Did you try it, or are you going to try something like this?
We haven't tried anything like that. Yeah, I mean, there's many different like permutations of the UI that we could try. The specific strings and icons that we picked were based on this research that we did in 2016. It's possible that like a flickering UI or dripping blood or something like that would make people have like a significantly different user behavior. Yeah, I think it's, we're trying to find a sweet spot between people, understanding what the warning is about without actually like significantly lowering the time they're spending on the internet, something like that. So
the main problem is that if you're not doing A/B testing, is that there is a lot of different users. Like if you put me some kind of URL with even one typo, I will notice it. And if you ask my dad, you can write it differently totally, and he will like, it's my bank because this is the page. So not doing A/B testing is, I think it will give you less accurate results, because you probably will ask people like me and not people like my dad.
So when we roll out the changes, sometimes we'll do it for like 1% of all Chrome users or something and measure the effects before we ship it to 100%. And in that way, we're using like our infrastructure to measure the differences in user behavior. But yeah, I agree that there are many different ways that we could have gone with this. But yeah, I'm pretty happy with where we landed now.
All right, while we get runners to the questions in the center of the room, I had the good fortune to see Emily give this presentation this morning to a group of Microsoft executives, and they asked some really interesting questions about user behavior versus web developer behavior. And is there any information you can share around what you've seen there around the implementation of websites that's maybe changed as a result of the work you've done in Chrome?
Yes. Yeah. So I think the question was about like, are these changes intended to, make users understand the risks of non-secure HTTP, or are they intended to convince developers to migrate to HTTPS? The answer is yes, right? We want users to understand the risks, but it's also kind of a win-win situation if it's causing sites to migrate to HTTPS. So yeah, the good news is we definitely saw on the transparency report, like over the last few years, a vast number of sites have migrated to HTTPS, but of course it's not just because of the changes in Chrome. It's because of the changes, around the ecosystem, which have also made HTTPS a lot easier and cheaper and more automatic to implement.
Hey. So my name's Nico. But I have a question kind of piggybacking off of the questions about A/B testing and kind of the results and how they've either one been communicated and kind of clicked down on and then re-vetted and then coming out with the next testing phase, kind of what you went through with 5 different types of URLs that you tried with this beta group of people. If a lot of this has happened from an internal perspective and you've gotten feedback from it, for those few users, I think 1,000 or plus, so to put a number on it, were there any sentiments gathered from them from your reporting that is out there that the vast majority can see? Because to your point, if I look at the URL, I get if I'm typing, I'm always going to look back up just to double check because everybody may not be the best typer in the world. So for what you said, saying, you start typing and it starts to alert me whether or not flashing and or a solid color being red good or red bad, green good, have you guys really vetted the feedback from the folks that you did kind of expose this to when you released it and then kind of maybe reverted back on some pieces of it?
So we've published the research about why we chose the word secure, the green lock icon, and the red danger triangle icon. And we plan to publish research about the EV stuff that I showed and also like the URL research that we're doing. I'm not sure if that's exactly the question that you're asking, but we do measure the metrics from Chrome telemetry as we're rolling these things out, which is actually how we decide like at what time is it appropriate to take the next step and show the warning on the next piece.
Okay, so target audience, and then that's the changes that you've went through and kind of what you walked us through today. Initially, was the concept because you kind of reached out to either a group of developers or a target audience, or it was something that you had in mind, pushed it out for internal POC or to this group of people or externals, and then it came back with some type of sentiment, or exactly how did you at least get to the baseline pieces that you've already been working
Yeah,
through?
a lot of the baseline research was research that we did, the offline research that I was talking about, Rethinking Connection Security Indicators from 2016, which was about, they did a lot of work to make sure that we got like a diverse audience of users that tried to reflect the actual population of Chrome. So it definitely wasn't just from a subset of developers or something like that. Certainly target at like the wider consumer audience.
Right. Okay, I think we are out of time for questions. I'm sorry. Please join me in thanking Emily for coming and sharing this presentation today.